You're asked to go ahead and graph the velocity function. So first of all, we need to have our axes labeled with our what's going on, velocity and time. You also need to have the appropriate units of each one. Now, this is a piecewise function here. So for our first piece, looking here, whenever you're between 0 and 10, you want to use this. That just says you double your input. So if you plug in 0, 0 times 2 is 2. Or I mean 0, sorry about that. And then we know this is a straight line, y-intercept 0, slope of 2. You could also find the other end of the line by taking your 10 and plugging it in. 2 times 10 is 20. So you start out at the point 0, 0, and go to the point 10, 20. Then we want to go ahead. Then we want to look at this one here. This one says whenever you're between 10 and 20 for your time, you're going to always be at a height of 20. So between 10 and 20 right here, you're always going to be at a height of 20. So I'm going to have this. Then we want to look at this one down here. So this one only goes from 20 over to 30. So let's take our 20 and plug it in here. We know this is going to be a line, slope of -2 with a y-intercept of 60. But our line only starts at 20. So if we take 20, plug it in, we get -40 here plus 60. So we get 20. So that's going to start right here where the blue line left off. So let's find the other end. So let's plug in our 30. -2 times 30 is -60 plus 60 is 0. So we start out here, and then we go to 30 and a height of 0. So we have that graphed. Now let's look at the area underneath the curve and figure out what it represents. Now it is one big trapezoid, or you could think of it as a triangle here on the left, triangle on the right, and a rectangle here in the middle. Now if you did think of just the middle of a rectangle, to find the area of that rectangle, you'd have to take your height, which is in feet per second, multiply it by your width, which is in seconds, and we get feet because you're dividing by seconds and then multiplying by seconds. In other words, the area underneath your curve represents distance because feet is the units for distance. So to calculate the area underneath the curve, we could do 1/2 base times height here for our first triangle. 1/2, it's 10 wide, and it goes from 0 up to 20, so it's 20 high. Then we have our rectangle in the middle, which is 10 wide and 20 high. And we have our triangle on the right, which is 10 wide and 20 high. So all we have to do is just multiply that out, and we get 400 is our area. But then we've got to remember to include our units, and that's feet. So how does this relate to the position graph? Our position graph at time 0 would also be 0 because we haven't gone any distance if you haven't started. Now, at time 30, our position graph would be at 400 because from here, the area underneath your velocity graph is distance. So from 0 to 30, the total area underneath would be where your position, your distance would be at 30 seconds, and that's 400 feet.